This lesson shows you how to solve inequalities. Inequalities are solved in much the same way as equations. You add, subtract, multiply, and divide on both sides to isolate the variable and find a solution. In this example, begin by subtracting 7 from both sides, giving 2x is greater than 18. Then divide both sides by 2 for the solution x greater than 9. There are differences when you solve inequalities. First, you can graph the solution to an inequality. Put a dot at x equals 9, the boundary of the solution, and shade the number line to the right. Include an arrow at the end to show that it continues. If the inequality was x greater than or equal to 9, then you would draw a solid dot at the boundary. Also, unlike an equation, an inequality has 2 checks. The first is a boundary check. Begin by rewriting the inequality as an equation. Then substitute x equals 9 into the equation. This gives 2 times 9 plus 7. Then 2 times 9 plus 7 is 18 plus 7, which is 25. And the boundary value checks. The boundary check verifies that you subtracted and divided correctly when you solve the inequality. The second check is an inequality check. Select any convenient value in the solution set, that is, any convenient value greater than 9, like 10. Then substitute x equals 10 into the inequality and simplify. 2 times 10 plus 7 is 20 plus 7, which is 27. And since 27 is greater than 25, the inequality checks. The inequality check verifies that the inequality symbol was supposed to be greater than and not less than. When you solve inequalities, sometimes you need to switch the direction of the inequality symbol. In this example, when you divide both sides by -2, you have to switch the inequality from less than to greater than. The reason for the switch is easy to understand. Consider the true statement, -4 is less than 6. When you divide both sides of this inequality by 2, the statement remains true. -2 is less than 3. However, when you divide both sides by -2, the statement is not true until you switch the symbol from less than to greater than. This is one of the things you must remember for this chapter. If you divide or multiply an inequality by a negative number, always switch the direction of the inequality symbol. So, to solve this inequality, begin by subtracting 12 from both sides. Then divide both sides by -2, switching the inequality from less than to greater than, for a solution x greater than -4. For the boundary check, rewrite the inequality as an equation and substitute the boundary value x equals -4 into the equation. This gives 12 minus 2 times -4 which is 12 plus 8, which is 20, and the boundary value checks. For the inequality check, use a convenient value greater than -4, like -2. Substitute into the inequality, and you get 12 minus 2 times -2, which is 12 plus 4, which is 16. And since 16 is less than 20, the inequality checks. Notice that if you had not switched the inequality and instead checked with a value less than -4, like -5, when you substitute into the inequality, you would get 12 minus 2 times -5, which is 12 plus 10, which is 22. And since 22 is not less than 20, the solution would not check. You would realize that you had made an error. The solution must be x greater than -4. You can see that an inequality check is important. Finally, don't leave your answer backwards. For this inequality, after adding 2 to both sides and dividing by 3, you have a solution 3 less than x, which is backwards. Flip this around for a final solution of x greater than 3. This lesson has been brought to you by the Math Department of Moreau Catholic High School, a Holy Cross school, bringing hope, building respect, being family, educating hearts and minds.